Okay, we're ready to start the second half of the lessons for this summer. So we're starting with section 1.4, angle measure. So let's define a couple of things first before we get to angle so we can understand the concept of angle a little bit better. First, we want to talk about array. Array is very similar to a line. By definition, I want to call array a set of points extending infinitely in one direction. All right, so here's a classic example of array. Rays do not have to go left to right. Rays can go in any direction. When we name a ray, we always name the end point first, no matter in what direction the ray is traveling or is extending. So let's just call these points A, B, C, and D. And let's go with X, Y, W, and Z. If I'm to name those four rays, I'm going to name AX and put the ray symbol on top. I'm going to name BY and put the ray symbol on top. I'm going to name CW with the symbol on top. And even DZ is named in this order because you always name that end point first. Also, the symbol always points to the right, even if the ray is pointing in another direction. So keep that in mind as you see the rays named throughout the book. If you have opposite rays, that means that they're traveling in opposite directions. That doesn't mean one has to go left and one has to go right, but in our case, that's what we're doing here. Okay, so ray OM and ray OP are opposite rays. Opposite rays can also be called a line or a straight angle. And that's a symbol for angle. Let me just show that a little bit better. Angle. I always put the slash through it. Your book doesn't. I do that so it doesn't look like I'm writing an L. So it can be a straight angle. And it's always 180 degrees. Always 180 degrees in a straight line, a straight angle, a line, opposite rays. Okay? Now what if these rays, OM and OP, are not opposite rays? Then we have what we are used to looking at as an angle. So let's shrink this a tad so I can have a little bit more writing room. So I'm going to have an angle. All right, this angle is the connection or the intersection of two rays at a common endpoint. See, so I have ray BA and BC intersecting at the common endpoint of B. That common endpoint is called the vertex. Okay, the two rays are called the sides of the angle. So I have side 1 and I have side 2. All of the space, or I could say all of the points that are in between the two sides. See if I can just kind of, that's not showing up very well, is it? Let me change colors on that. Let me go with gray. all of the points inside. And extending on forever and ever and ever on out as that angle expands and grows. All of those points are in the interior of my, that doesn't want to write very well, does it? There we go, interior of my angle. And then all of the space on the outside, of course, is the exterior of the angle. Now I want to talk to you about naming the angle because this is really significant. So if you need to get these notes down, you can stop the video now because I'm about to erase some things and I want to talk about how to name an angle. It's really important. All right, so let's draw another angle here. And I think I'm going to draw there. Okay. So let's say X, Y, Z, and we'll put W in the middle. Okay, if I am wanting to name this angle, this entire angle, and I'm going to put a symbol in here that we'll use to identify what angle we're talking about. If I want to name that angle that has the sides YZ and YX, I can name that angle using the three letters that are on the angle. I would say angle, and like I said, I put the slash through it. Then I put a point on one side of the angle. In the middle, I put the vertex point. And then the last letter is a point on the other side of the angle. So if I'm naming the angle that I just marked off, I can call that angle ZYX. I can also call it angle, the side, the vertex, the other side. Those two names name the same angle. Now, another way to name an angle is simply by its vertex. Okay, so in some cases, I could just name this angle Y. But I don't suggest it using the one letter in a drawing like we have here because we have multiple angles at angle Y. So it wouldn't be a clear communication of which angle I'm talking about. If I say angle Y, does that mean I'm talking about angle WYX? Am I talking about WYZ? Or am I talking about XYZ? By using the one letter in a case where there are multiple angles at the same vertex, there's no clear-cut way to know which one you're talking about. So if you have a singular angle like you do up here, and you want to use the name of the vertex, that's great. But when you have multiple angles at the vertex like here, this is not a good option at all. Now we can also use numbers to name angles. So I could name, excuse me, I could name angle WYX. It can be the same thing as angle 1. And I can name WYZ angle 2 if I want to do that. And I use the numbers a lot. That's my pick. And if I wanted to name the whole big one, maybe angle 3, I would have to concoct some way in here to make it understood that I'm talking about that whole angle. So when there are multiple angles at that vertex, again, you're going to have to be very clear cut, and usually the 3 letters are the best. Okay? So that's a little bit about our angles, and let's go on and see what else we know about angles. Angles are measured in degrees. And the tool that is used to measure angles in degrees is called a protractor. And we will use protractors throughout the year, for sure. I do have several in the room, so if you get caught someday without a protractor in your backpack, I have got at least a full classroom set. So we've got several in the closet in the room that you are more than welcome to use. But let's talk about some good practices for using a protractor. First of all, notice that the bottom numbers go from smaller to larger on the inside, and then from smaller to larger back to the right on the outside. So you have to make a determination by the look of the angle. Is this a large angle or a small angle? Am I going to use the top number or the bottom number? And we'll talk about that more in just a second. Also, there's going to be either a mark or maybe even a little hole in your protractor right in this area, and that is where you will always put the protractor over the vertex of the angle that you're measuring. You also want one of the rays of the vertex to extend through 0. Okay, now don't lay your angle down here and come down there unless the 0 is on that part of your protractor. You want, again, to be right here, to have your vertex in that hole or on that mark, and then you want one side to extend through 0. And it may extend this way, but you're still going to extend through 0. Now, this angle is smaller than 90 degrees, right? It's smaller than a right angle. So you know you're going to be reading the inside numbers. So this particular angle, angle E, I can call it because there's just one angle there, or I can call it angle FED, or I can call it angle DEF, or I can call it angle 1 if I want to put the 1 in there. That particular angle has a measure of 50 degrees. That little M means the measure of that angle. Just like when we're talking about the measure of a segment, we take the little top off. Okay? Now, as I measure angles in degrees, remember, and I know you've had this in elementary school or middle school. I remember the kids this year had a really good background in this vocabulary, so I'm sure you do as well. If we have an angle that measures less than, less than 90 degrees. If an angle is less than 90 degrees, it is called an acute angle. If an angle is equal to 90 degrees, exactly equal, then we have a right angle. And when we draw a right angle, lots of times instead of telling us we have a right angle, the authors of your book will use this symbol. They'll square off that angle, and that, again, gives you the power to know, oh, that's a 90-degree angle. Okay, that's what that symbol means, a 90-degree angle. All right, now, if our angle is greater than 90 degrees, we have what we call an obtuse angle. Whoops. And then the following angle is not in your book, but an angle then that drops down and is greater than 180 degrees is called a reflex angle. And we will just refer to it every now and again because of a specific angle that we'll see. Okay? So I believe you know acute, right, and obtuse, but that reflex may be a new word for you. So keep that in mind. Okay, here we've got a demonstration again of the right, the acute, and the obtuse, and I like how they pointed out to you that symbol for the right angle. Okay, let's look at this this figure below. It asks us to classify as right, acute, or obtuse, and then use a protractor to measure the angle to the nearest degree. Unfortunately, I can't measure it or if I can, I haven't learned how to yet on this app. So we'll just sort of go through the right, acute, and obtuse piece here. Angle AFB. So that means from side A to vertex F to the side with B. This is the piece that they're asking us to classify. Well, that is obviously smaller than a 90-degree angle. So here we have an acute angle. Okay, now I'm going to erase that marking because I don't know what else they're going to ask me for. Okay, next we have CFA. So from C to F to A. Right there. Now, if this side over here is 90, and it tells us it is, and I've got a straight line across here, that means this has to be 90, because 90 plus 90 is 180 degrees in that whole straight line. So CFA has to be a right angle. Okay? Now, let's look at the next one. We have from A to F to D. Now that extended beyond the right angle that we know. So we have an angle that's bigger than a right angle. So here we have an obtuse. Okay, from C to F to D. So let's look at what we've got here. Start at C, whoops. Start at C, go to F, and back up to D. This little angle. Now that angle is part of a 90-degree angle, so it's obviously less than 90 degrees, so once again, we close out with an acute. Okay? Here we have another construction. Again, this is one of those things that if time permits, so I'm not going to be really concerned about that right now. But I do want to talk to you about congruent angles. We talked about congruent segments in a previous section where we said a segment AB would be congruent to a segment XY, and that would mean they have the same measure, they're the same shape and size. Well, that's true for angles as well. If I have the measure of an angle ABC, and it's equal to the measure of an angle DEF, as illustrated here, both are 65, then I can say that angle ABC, here's that congruent symbol again, is congruent to DEF. That means they're the same shape and the same size. I could cut them out and turn them together, and they would match up. Alrighty. Down here at the bottom of the page, and I hope we didn't have a glitch there. I looked down and the timer had stopped, so we may have had a little glitch there. If so, you might want to review this note again to make sure you see what I was saying on that page. Here we have an angle XYZ, that's the entire angle, and we are told that ray YW is a bisector of the angle, so it's an angle bisector. If ray YW is an angle bisector, then that means that this little piece of angle and this little piece of angle have to have the same measure. Okay, and I can add those two angles together and get the whole angle XYZ. A line can be an angle bisector, a ray, a segment can be an angle bisector. Okay, let's look at this angle, this example 3 up at the top of the page. These angles, one thing I want us to look at with this is how when I read a problem and I read the directions, how I like to go over and mark my diagram. So I like to, when I do these, I like to always put the diagram in my work. It helps a lot when you're working the problem. if you don't need it, that's okay, but don't be lazy and not do it just because that you just don't want to do it, okay? It can help you be more successful, so be mature enough to make that decision. Now, it tells us that KJ and KM are opposite rays, so that confirms for me that I have a straight line over here. Okay? KN, this ray, KN, is bisecting JKL. So when I look at from J to K to L, that angle in there, KN is cutting it in half. So that means that this piece and this piece are congruent. Remember those little hash marks that we used with segments? I use them in angles probably even more. So I know that NKL is the same measure as NKJ. All right, now let's go back and pick up where we left off. If the measure of JKN, that's this here, is 8x minus 13, and from N to K to L is 6x plus 11, we have to find JKN. That's this angle. Well, since we have a bisector, we know, as they have indicated over here for us, our two angles have to be equal. So we set equal the two algebraic phrases that have been given as their measures. Then we solve for x, and then we take that x and we answer the question with it. We were asked to find JKN. So we have to plug in. Again, be real careful when you have to find the measure and then plug in, because if you miss the measure, you're going to miss the plug-in part. Be real careful with your basic algebra. Now let's look at the one that they gave us, and let's see how we can do with that. I think what we'll do is just redraw this diagram. It'll be a little bit rougher than theirs, but we still know that these two are equal. This is my K. I've got L out here and N. If this was my homework paper, I'd be using a straight edge. Okay, now, we have that same information we're given. Now it says, suppose JKL, that's the whole thing. That's the big angle from J to K to L. Suppose that is 9y plus 15. And that JKN, that's the little half piece, is 5y plus 2. Well, I don't know about you, how you would think through that. There are a couple of different ways to think through that. But I think what I would do in that case is double the small one. Say, well, if I have two 5y plus 2's, that's equal to the whole big angle. Because if I divide the 5y plus 15 in half, I'm going to have some fractions. And I don't yet know your particular class's fondness or aversion to fractions. So right now I'm going to stay away from it if I can until I get to know you all better in the fall. But let's go ahead and work this out. I'm going to distribute my 2. This one's not too bad. Subtract the 9 from each side and the 4. So y is 11. They say find JKL. So I've got to plug 11 in for y. So 99 plus 15 is what, 114 degrees? So the angle that they were asking us for is 114. Okay? Again, I've got this a bisecting an angle, this construction. We may look at that, we may not. Alrighty, let's make sure that we're in good shape here to do your assignment. We'll just run through a few of these. Name the vertex of angle 4. If I look at 4, the vertex would be point U. The sides of angle 3, the sides of an angle are rays. The rays have to be named with the end point first. So we have XW and XU. What's another name for angle 2 right there? I could say angle Y, but you see all those angles at Y? That's not my best choice. So I'm going to say XYU. I could have said UYX. Another name for UXY. That sounds familiar. UXY. Well, that's old angle 1, isn't it? Okay. I think we've done enough examples of these. We've got our sides. I think you're good for that. Don't want to leave you hanging on something that might leave you unprepared. But if ever I do overlook something and you feel like you're unprepared, you know you can always comment and ask me, and I'm happy to help you. This challenge problem, again, do not shy away or be afraid of the challenge problem. I love this challenge problem. Let's work it together and study it, and you'll probably see one similar to it around exam time, so you want to make sure that you understand this problem. It's not difficult, but it's different, so it may make you doubt your thinking, but I don't want that to happen. I got to have plenty of room up here. Now let's read it first together, and if by chance it doesn't make sense, we're going to read it one time through together, and then we'll go back through it again and break it apart, because I want you to see what's happening in this problem. Ray MP bisects angle LMN. Then ray MQ bisects LMP. MR bisects angle QMP. If the measure of angle RMP equals 21, find the measure of angle LMN and explain your reasoning. Now, a lot of bisectors are going to be in the same angle. So I am going to, even though I'm sure it's going to be off scale, I'm going to make a really big wide angle so that I have enough room to decipher and put these angles in here, these bisectors, okay? So if MP is bisecting LMN, then here's LMN. And I've got to put MP in here to bisect that. So up here is P, and I have just bisected, so those two were the same. Okay, now we've taken care of that piece of information. Now MQ is going to bisect LMP, so I've got to put a bisector in here. So that's going to mean these two pieces are equal. Now notice how I've used 2 hash marks here so that I could pair those together, and then 1 hash mark previously. So now again I have a visual of what's equal to what. So I really know that 2 reds make 1 black, don't I? 2 reds equal 1 black. I don't know if that's going to help me or not, but I just felt like I needed to write that down. All right. Now MR is going to enter the scene. Let's see what MR does. MR is bisecting QMP. So right in here, we have MR, and it's bisecting. I'm putting 3 hash marks there. So 2 blue equals 1 red. All right. Now it tells me that RMP is 21 degrees. And we're supposed to find the big angle. We can do that. All right. If RMP is 21, isn't the other angle right beside it that we have marked with blue 3 hashes also 21? And then these two go together to make the red angle. See how that's the red angle when you put those 2 blues together? So 21 plus 21 is 42. So that means that this one here is going to be 42. See how our marking them congruent made it easier to make that prediction? Then, as you notice, the 2 reds go together and make one of the black angles. Well, if these 2 were 84 together, wouldn't this one on the outside be 84? Because they're marked the same. So I have an 84 degrees and an 84 degrees. That tells me that the whole big angle that they're looking for is 168 degrees. That's a fun one. I have one even more fun than that I'll probably pull out soon after school starts. All right, this is a chapter review. You need to read through this, look over it, and see if there's anything on here that you're uncomfortable with, anything that's not making sense. Again, send it to me, and we're halfway through now what I want us to do before you start back to school. So any questions over these first sections, let me know, okay? And I'll see you again in Lesson 5. Bye now.